everyone. In this video, I will show you how to compute the edit distance between two strings using dynamic programming. So what is the edit distance? Okay, so in this problem, the input we have is two strings A of length n and another string B of length m. Okay, and we want to output the minimum number of edits that is needed to transform A into B. Okay, what do I mean by an edit? Okay, so three types of edits that we are allowed are the following. Insert a character. You can also delete a character. Finally, you can also substitute or replace a character. So let me give you an example. Okay. So let's say A is snowy and B is sunny. Okay. So how do we transform A to B using these three types of edits? Okay, so let's say we start with snowy, right? So we can say, insert S at the beginning. Okay. Then we'll get the following. Okay. So then we can replace or substitute, okay, the second S with U. Okay, so we have the following. Not quite. So we have SU and okay, UI. Okay. Now we can. Okay, so we can delete this O. Okay. That will give us the following. Okay. We can also then delete the W here. Okay, so we'll get okay, and finally, we can insert another N before the Y, right, to get the word sunny. So in this example, so the total number of edits is you can see 1, 2, 3, 4, 5, right? But this is not but this is not the smallest number of edits needed. Okay, so I will show you a different transformation that uses a smaller number of edits. Okay, so let's again, here we have Snowy. Okay, so the first thing I will do is I will the first thing I would do is I will insert a U between S and N. Okay, so we have the following. Okay, and then I will delete the U. So then we'll get oh, I'm sorry, we will my bad there. We will replace the character O, the letter O, with N. Okay, we'll get okay, and finally we can delete the W letter. Okay, so we delete the letter W and we'll get Sunny. Okay, so here the total number of edits is 3. Okay, and you can check that this is the smallest possible. Okay, so so the edit distance between Sunny, like between Snowy and Sunny is 3. Okay, all right, so how do we compute the edit distance using dynamic programming? So here's an algorithm using dynamic programming. So let me define the subproblems as follows. So let E, D, I, and J be the edit distance between the prefix A1 up to AI and the prefix B1 up to BJ. Okay, so this is a smaller problems compared to the original problem. Okay, so first of all, let's talk about the easy corner based cases. Okay, okay, so basically, first of all, what is ED of 0J? Okay, so ED of 0J is what is the edit distance between an empty string? Okay, and b1 up to bj, right? So if you have an empty string, the only way to transform it into the other string is you have to insert j characters, right? You insert b1, and then you insert b2, so on up to bj, right? So this is easy, and that should be j. Similarly, ed of I0 is I, right? Okay, so these are the corner cases. All right, so now what is the recursive structure of these subproblems? Okay, so let's look at the edit distance between A1 up to AI and B1 up to BJ. Okay. So what is the recursive formula? Okay. Let's visualize this a little bit. Here we have A1, A2, AI minus 1, AI. Okay, and here we have B1, B2, and BJ minus 1, and BJ, right? Okay, so how do we transform, let's say, the first string, right, to the second string? So we have three options. Okay, so we have three options. So the first option is, okay, so we need to make the last two characters similar to each other, right? So one way to do it is, say, we insert bj at the end of A1 up to AJ. Okay, so basically we insert bj here at the end. Okay, and I'm sorry, A1 up to AI. Okay, so then we'll have, basically what we'll have is A1 up to AI and then bj at the end. Okay, and then transform A1 dot up to AI into B1. Okay, so now the last two characters match, right? So you can try to transform this part, A1 up to AI, into B1 up to BJ minus 1. Right? So what is the cost? So the total the number of edits, okay, is 1 for the insertion, right, plus the number of edits that you need to transform A1 up to AI to B1 up to BJ minus 1. Okay, So note that this is a smaller subproblem. Okay. Compared to EDIJ. Okay. Okay, so then we have the second option. Again, we have so we can delete AI. Okay, because okay, so we can delete AI and say and transform A1 up to AI minus 1, right, to B1 up to Bj. Okay, so the number of edits in this case is 1 for the deletions, right, plus the number of edits that we need to transform A1 up to AI minus 1 to Bj. Okay. So the first option corresponds to an insertion, and the second option corresponds to a deletion. So what is the third option? Okay. The third option corresponds to, you can guess, the substitution. So basically what we do is we say we replace AI with Bj. Okay. So the cost. Okay. So the cost here is 0 if AI is already the same as Bj. And 1 if AI is not equal to Bj. So then you need to actually replace AI with Bj. If AI is already equal to Bj, then there's no cost, right, associated with that. Okay, and then you need to transform A1 up to the prefix A1 up to AI minus 1 into B1 up to Bj minus 1. Okay, so the number of edits in this case would be the number of edits that you need to transform A1 to AI minus 1 to B1 to Bj minus 1, okay, plus let's say diff of AI and Bj. Okay, so so what is this? So this is the diff function is basically just the cost is just to denote the fact that if AI is different than Bj, if AI is different from Bj, right, then you need a cost of 1, right, to replace AI with Bj. Right. And 0 otherwise. If AI is the same as Bj, then you don't need to actually replace AI with BJ because they are the same characters, right? So okay, so you don't know. Okay, so to transform the prefix A1 up to AI to the prefix B1 up to BJ, right? So you need to do you need to um, you need to do you need to follow one of these three options, and you okay. So the problem here is that we don't know which of these corresponds to the smallest number of edits, right? But we can try. But we can try all three of them, okay? And take the one with the minimum number of edits. So okay, so then we have the following. We have edij is equal to min of ed I minus 1 j plus 1. Okay, so this corresponds to the second option. Ed I j minus 1 plus 1. This corresponds to the first option, right? Ed of I minus 1 j minus 1 plus diff of AI and BJ. Okay, so we pick whichever option that gives us the smallest number of edits. Okay, so okay, so what does the whole algorithm looks like? Okay, we can do the following. Okay, so okay, so for I from 1 0 1 2 up to n, and for j is equal to 0 1 2 up to m. Okay, okay, so if I is equal to 0, then we set then ed ij is equal to j. This is the base case. Else if j is equal to 0, then similarly edij is equal to I. Okay, now else you can just so otherwise we can just use the recursive structure that we have above. Okay, so edij is equal to the minimum of ed I minus 1 j plus 1 ed I j minus 1 plus 1. Okay, plus ed of I minus 1 j minus 1 plus the difference between AI and BJ. Okay, and finally, okay. So let me remind you that we were trying to find the edit distance between the whole string, A and B. So so we want to output ed of n and m, which is the edit distance between A and B. Okay. So so the running time, it's not so hard to see that so you have for loops, two nested for loop. The first loop runs from 0 to n, the second loop runs from 0 to m, and in each of these nested iteration, the amount of work that you do is constant. So the running time is just n times m. Okay, So now let me try to provide you an actual implement to show you an implementation in Python on LeetCode of the edit distance problem. Okay, so here we have a function that takes in two strings and it is supposed to return the edit distance between these two strings. So I just let n and m be the length of the two strings as described in the lecture. Okay, and because I prefer the index to start at 1 instead of 0, so I just add a dummy space character in the beginning. We never touch it, so that should not be a problem. Okay. Here I initialize the dynamic programming table of size n by m, just like in the lecture. Okay, and then I will fill in the dynamic programming table as described. Okay. Again, we have two base cases. When we fill out the dynamic programming table ed. Okay, when I is 0, you need j insertions. So edij should be equal to j. When j is 0, you would need I insertions. Okay, so edij here would be I. Otherwise, you have the non-base case, which you can compute edij recursively based on the three options that we described in the lecture. Okay. Also, I have a helper function diff that takes in two characters and returns 0 if they are the same and returns 1 if they're different. Okay, so this basically tells you in the third option whether or not you need an actual replacement if the two characters are similar or different. Okay, so the code should run as expected. Alright, so I hope you enjoy the lecture and see you in the subsequent videos. Goodbye.